Alrighty, I think we're rolling, we're good to start. So this is the first video lesson for your Flamingoes Math class. I'm going to try to have one video out, two videos out for every math class for the month of May. It's going to be 2 videos because YouTube gets fussy if the video is more than 15 minutes long. So I'm going to try to keep every video to under 15 minutes, and then I'll probably upload 2 per class. So first things first, let me see if this is something you can read with the setup I have. Hopefully you can. Differential equations. I hope you can read that. Maybe what I'll do is for these videos specifically, I will grab a better marker and see if a darker marker will do the trick. So let's give this a go. Let's see if this works better. I think that's better. Okay, cool. So let's begin. So a few weeks ago, maybe you guys remember, we started talking about differential equations a little bit. So pretty much the way a differential equation works is you have some unknown function, let's say y, and what you have to do is you have to find what y is based on other information given to you that has to do with y. Alright, so for example, if I said y is the same thing as y prime, so that means I'm telling you that the function y, because remember y is a function of x, I'm telling you that this is exactly the same thing as y prime, which means the derivative of the function. So what I'm asking for in this question up here is what function y satisfies this condition where the function and its derivative are the same thing. So that's where we got to start. And well, let's go through this one first. We'll see if we can figure it out. You guys may have already got it, so it'll be a little while for me to figure out how much time to give you guys to figure this out, but I'm hoping you guys can get this one because it's not overly complicated. If I gave you a function, y equals e to the x, let's say, then if I asked you for the derivative of that, y prime in this case happens to be e to the x. So for this particular question, that's our answer. Hopefully it makes sense. Good thing about this being a YouTube video is if you get lost, you can pause it, and also these are videos you can watch at home in case you guys run out of time in class. So if you look, the question is, what function y satisfies this case? So y equals y prime. What function satisfies that? And so for this one, I've given it to you guys. Y equals e to the x satisfies this condition above because this function is special in that its derivative is exactly the same thing as the original function. And so that's what this question up here is asking for. So your answer to a differential equation question like this is find out what y is. And y should be in terms of x. Remember that e is a number. So this answer here, e to the x, is in terms of x because it's just got a bunch of numbers and x. If it was a bunch of pi's or e's or c's, like the speed of light, with an x, then that answer is said to be in terms of x. So you're good if your answer is the other side of the equal sign of y. So let's do another one. If you're confused, sorry, we'll figure it out. Bear with me. So let me give you another example. So we'll say y double prime is equal to for y. So that's the question. Y double prime equals 4y. Double prime meaning the second derivative. Alright, so that's y prime, which is be the derivative. Prime again, that's the second derivative. So y double prime, the second derivative of y, is the same thing as y times the number 4. So we need to find a function that fits the bill. And what we could start with is a really good guess to make to start. Usually has something to do with e to the x. Because the e to the x function doesn't change a whole lot, it's really good as a starting guess. Later on, maybe in this video, we'll see how the time goes. Later on in this video or in the next video, I will show you how to systematically figure out what the guess should be. And it does get a little bit complicated. I'll try to keep it straightforward. It's going to have a couple of Greek symbols, maybe, just to avoid confusion between my notes and what I'm showing you guys. But we'll get to that. So y equals e to the x, that's our guess, all right? This is what we are guessing, that this is what y might be. Now, the only way we can really figure it out is if we take the first derivative, which is e to the x, because it's the same function, and we don't need just the first derivative, we need the second derivative. The first derivative doesn't actually matter at all in our final answer, so that's nice. So we need our second derivative to be 4 times bigger than y. But our second derivative here, the derivative of e to the x from up here is e to the x. The derivative of that is just e to the x again. So this is telling us that what our guess is that if y is e to the x, that means we're saying that this side over here should be 4. Hope you can see that. 4e to the x. That's what we're saying because our guess was that y is this e to the x part over here. All right? But over here, when we did the calculation down here, we get that y double prime is just e to the x. So what we have with this guess of y being e to the x is it doesn't make any sense because what we're trying to say is that e to the x is the same thing as 4 times e to the x, which doesn't really make any sense. So we need to try something a little bit different. I'll say pause the video right now if you guys want a couple of minutes to try to figure it out, and then I will put in the answer. So pause it now if you guys want to try. Alright, so the answer for this one, I'll give it to you. Hopefully you guys got it, but if not, that's okay. You're new to this, we'll figure it out. So, if y is e to the x, we know that doesn't work, but e to the x is kind of a good guess, we said, because we want the functions to look kind of similar to their first and second and third and fourth derivatives, right? So, the answer to this one, as long as I haven't made a major error in my thought process, should be e to the 2x. And so here's how that works. This one, to explain how I know it, it's just after you've done a few differential equations, this is one of the ones that you will know. You'll know how to solve this type of differential equation where there's no bells and whistles added to the question. It's a fairly straightforward question once you've seen some more complicated DEs, differential equations. So, the derivative of this function, we need to figure out the first derivative, and then we need to figure out the second derivative. So we need to take the derivative twice. Now the derivative of this function, I know you guys had trouble with this, so watch closely, is e to the 2x, just like you had before. So it's the original function times the derivative of the exponent, and the exponent is 2x. Right up here. So the derivative of 2x is just 2. So it's this whole thing multiplied by 2. So there's 2e to the 2x. Alright? But we don't need the first derivative, and that's a good thing because this 2 doesn't really make sense with what we've got going on up there anyway. Now, if we take the second derivative, we're taking the derivative of this guy down here. And so what we can do is, let's start with taking the derivative. Don't worry about the 2. Don't try to do this as a product rule kind of thing from last month. Just don't be frightened by this number out here, because up here we technically had a 1 out front and it didn't cause us any problems. So just don't stress out about this 2 out in front. And if you take the derivative of this, then you're still going to have the 2 at the beginning from right here times the derivative here. Let's figure this out. So the derivative of e to the 2x, well, we already did that up there. So that's going to be e to the 2x, as always, times the derivative of the exponent. And the exponent, again, is 2x, right? So the derivative of the exponent, 2x, is just 2, right? So that's multiplied by 2. So now we have 2 2's out here, one from before and one from this derivative. So this was from the first derivative, and then when we took the derivative again, that 2 never left the exponent, so we have to multiply by 2 a second time. And if we want to simplify that answer, 2 times 2 is 4, and we get 4e to the 2x. Now, if you look, our guess for y was that y is e to the 2x, and our e to the 2x shows up right here, right? So that's our e to the 2x covered. This is our y, and then it's just all 4 on the outside. So what we've got is y double prime, the second derivative of y, is equal to 4 times the original function y. And so that gives you the answer to this differential equation. Hopefully that makes sense. I'll leave this up for a moment and then we will move on. I won't leave it up for too long because this is going to be a YouTube video, so you guys can pause it and you guys can watch it later. Hopefully you've got most or all of that down by now. I apologize if this is too slow or too fast. Perhaps what I'll do before I go on to another video is I want you guys to write this down, and I want you all to actually, no, I'll come back to that another time. Never mind. So hopefully you guys have it down. Actually, those of you who I just taught, you should have my email written down somewhere. So if you have questions, concerns, send me an email, and I'll see if I can change the way this is going. This is 12.5 minutes, so I'll do one more example, maybe. Yeah, sure, one more example. All right, let's say y double prime. I might have to make this a little bit quick because I got to make sure this video finishes under 15 minutes, or I'll at least, you know what, I'm just going to write this down and then I'll stop it here. So y double prime is equal to negative y. That's the question. I think we covered this before, and let me make sure that it makes sense. Yep. All right, so this is the question, and your hint before you go to watch the next video is that the answer has nothing to do with e to the x. It's got to be in terms of x, but it's got nothing to do with Euler's number. It's got nothing to do with that exponential function e to the x. We don't need it for this question. So give it a thought, and I will see you guys in the next video. Hopefully this is going well, and I hope you had a good long weekend. I'll be back in a moment.